Okay, so these are your notes for states of matter. And the first thing I promise you is on the test, you might want to take out a highlighter or underline this. Okay, you have this in front of you. So, what determines the state of matter? State of matter meaning solid, liquid, or gas. What determines it? Well, it's the amount of kinetic energy and the strength of the inter or intramolecular forces. We're going to talk about what those are in a minute. But kinetic energy is the measure of how fast the molecules are moving. So if they're moving faster, a solid can turn into a liquid, or a liquid can turn into a gas. Okay, that's what this means. Okay, let's talk about two definitions that I promise are on the test. Intramolecular forces, which is the bond between atoms. An example, if I had H2O, it's that bond between the oxygen and the hydrogen. Okay? That is called an intramolecular force. Okay? Just going to tell you the other one is called intermolecular force. On the other side, I will talk about these in detail in a minute, but I just wanted to show you the difference between them, and I promise you need to know them. It's kind of like the topic of this chapter. It's the attraction between molecules, not the actual bonds. So, for example, if I had the oxygen with hydrogen, but then I had another one nearby, this is talking about is the attraction between the different molecules. Do you see the difference? So these are attracted to each other. That's why water has a high surface tension. Okay? That's a force that's holding these water molecules together. Okay, now that we know the difference between the two, they're actually separated into two different categories. There are the ones where we're talking about the differences in bonds. Okay? It turns out that the weakest bond is the covalent bond, and that's anytime you have a metal with a nonmetal. So if you don't know what a covalent bond is, these are the three categories: the covalent, metallic, and ionic. The covalent would be anytime you have nonmetal with a nonmetal, okay? And it can be either polar or nonpolar, okay? Yes? Oh, sorry, it's two nonmetals. Two nonmetals. Thank you. Okay, so this one is the very weakest. Let's give examples. Can anyone think of a covalent molecule, like something that is made up of two nonmetals? Okay, water would be an example. So H2O is an example. Write examples down. I think it helps you to learn this. Another would be like carbon dioxide. Notice they're both nonmetals. Okay. Another one is even carbon monoxide, where you have carbon with oxygen. Okay, do we understand what this is? So this is like a weak bond. And let's see, does it say it in here? Not really. So we're just going to say that this one is the weakest. And that's important to know. Any questions about that? The bonds are not very strong between them. Okay, the next one is like medium strength. We have what's called metallic bonds. Anything that's a metal from the periodic table. So if I had like a chunk of magnesium, a chunk of gold or silver, these would be considered metallic. They are, even though this says strong, I'm just going to say they're medium so that it can help you to separate them when you have to put them in order. Okay? So yell out examples of metals. Anything black on the periodic table? What? Iron? What? Gold? Silver? Copper, yes. Thank you. Okay, good examples. We're ready to move on? Okay, ionic, these are very strong. It says it right here. They're very strong. And of course, it's when you have a metal with a nonmetal. Some examples like sodium chloride or magnesium oxide are just a couple. Anytime you have a metal with a nonmetal, okay? We're adding one last category here. Add it to your notes. It's called the covalent network solids. It should have been on here. And these are the very absolute strongest. Okay? Off the top of my head, examples would be diamonds and sand. Let's just put those two. Those are the most common you'll see in the homework. Okay? So, do we understand that if I had a list of molecules, we could separate them based on the attraction of forces between them? So, like, if I had a list of molecules, like, for example, I'm going to make one up right now. I have carbon monoxide, I have sodium chloride, we'll say diamond, and which one am I missing? Silver, okay? Let's do this. Put them in order of strength. This is the kind of thing you do for the test and for the homework, so this is like practicing it. Knowing that the covalent network solids are the strongest, by the way, I put them in order here from greatest to weakest. So covalent network solids being top, ionic, metallic, and then covalent. Okay? So let's do this. Which one of these is the absolute strongest force? Okay, you get the idea. Which one is next? Anything that's ionic. Oh, you know what? This was supposed to be NaCl. Okay, now that changes things. What is it? What is the third one? Okay, yes. You're literally just seeing what category they go in and placing them in order. Yes.
What is the formula for sand?
It's longer and I don't have it memorized, but don't even worry about it. On the test, I would not hold you accountable for it. Okay, now that we are done with the left side, let's talk about the right side. The first thing I want you to know about the right side, I already told you the definition, that it's the attraction between molecules, but I want you to write somewhere up top and make it clear when you study that if the bonds are covalent, then they can be intermolecular forces. So all I did so far was add that it is a covalent bond. Just covalent. Make sure you know it's covalent, because now, if it's covalent, if it's that weakest one, then all of the covalent ones are broken up into 3 categories. And they're written right here for you. Okay, so the first one, which is the weakest, I'll have you write that down, that it's the weakest. Can I go ahead and write middle and then absolute most? Okay, so between these forces, the ones between molecules, there's the dispersion forces, which are, let me give you examples. You could read all that. It's a lot of good information, but I like to get straight to the point. What I would say about it is these are usually going to be a noble gas. So if you had to compare and you recognize that it's a noble gas, it would be considered a dispersion force. If it was nonpolar, okay, this is where the students dislike this lesson, because you kind of have to go back to knowing what polar means. Do you guys remember what I said polar is? Is it even or uneven?
Uneven.
Okay, it is uneven, okay? If this is nonpolar, that means it's a molecule that is even. So an example of this would be like carbon with hydrogen, where it is perfectly symmetrical. The stuff that you didn't like last time, you kind of have to remember it a little bit, not too much. Like you can wing it if you don't remember it. Okay, that's one example. Another, I'm going to give you one other example that I remember just off the top of my head. This one is even because it's like a mirror image, okay? So this is considered nonpolar. I think you should write my examples because for the homework it helps you.
Is the one that you wrote with like hydrogen, is that one polar?
It's nonpolar because it's even. If you remember, polar means uneven. So these are both nonpolar. Okay? Next, we have dipole, dipole. And if I had to just give it to you in one word, I would just say it's anything that is polar. Okay? Meaning it's uneven, like this. Remember, there was like a curve there, or this. It's not 100% symmetrical. Okay? And then hydrogen bonds being the last one, and the strongest of the covalent of the intermolecular forces. But they make it very clear it's only considered a hydrogen bond if the hydrogen is bonded with fluorine, oxygen, or nitrogen. Underline that part. You need to know that. Okay, so let's give examples. If you have hydrogen with fluorine, if you have hydrogen with oxygen, if you had hydrogen with nitrogen, kind of like NH3. Okay, these would be good examples of a hydrogen bond.